All right. So I'm going to go through this quick because you should be good with this. Hydrogen has a single bond. Okay? Hydrogen has single bonds, a dot and an X. So how'd you guys do it? The dots, X's, or the dashes?
Dash.
You do both? Some of you said. All right. So I'll just do both, I guess. So there's that. F looks exactly the same, except you need the dots around it. So it would be the same thing. If you had X's, that's fine. So that's H2 and F2. O2 is a double bond. I told you it would just help if you memorize that. Okay, another way to do that with the dots would be dot dot XX. Again, I'm being lazy with the X's, but it really doesn't matter. It could be all X's, all dots, dots and X's, as long as you have the right number of symbols. So you're sharing 4, and they each have 2 pairs. Nitrogen is a triple bond. Again, if you memorize that, that would help. It doesn't really matter where these 2 dots are. Same thing here, doesn't really matter. If you have 2 dots here instead of there, that's fine. Okay, triple bond there, so what does that mean? 6 electrons in the middle, they're sharing. And again, they do that because they want a full valence shell. That's the only way to do it, because they have dots left over after one single bond. CO2. CO2 has 2 double bonds on either side. Again, the lab is supposed to help with this stuff. That you see it, you draw it, and you see it in class and homework. You see it a bunch of times, and then you just remember. So if you can just memorize, O2 is a double bond, N2 is triple, CO2 2 double. You know, I know there's a lot to memorize in school, but that just really makes it easier. You don't have to think about it, and I'm all right with that. So that's CO2. So all those are nonpolar, just to review that, right? They're bonded to themselves. That's pure nonpolar, 0 difference in electronegativity. This is nonpolar, but the bonds are polar. I'm going to review that again today. We haven't really taken notes on that. And then H2O, if you can't do the dot structure for water at this point, you are in trouble. It cannot be linear. It must have a bend to it. It looks like 90 degrees. But this is technically not. It's actually 104.5 is that bond angle. You do not need to know that, but that's water. If you have the dots, then it's dot X with an H, dot X with an H. So either way, it's the same thing. Water is polar because it's asymmetrical with your dipole going towards oxygen, partial negative, partial positives. Just reviewing. The more you hear it and see it, the better. Questions on that? Okay, flip it. All right. We do not have time to go over every one nice and slow. I will read all the answers and go over maybe like 4 or 5 of them, okay, on the board. I don't really give a whole lot of notes on this. This is kind of how I teach it because we kind of already have learned this, sort of. Some of these are harder than others. So here we go. All right, number 9, or 7, I'm sorry. So one thing I neglected to tell you yesterday, sorry, is that an element by itself. So number 7 technically is K solid, and the oxidation number would be 0. Probably everybody put +1. The reason it's 0 is if this thing was made of pure potassium metal and I was holding on to it, I wouldn't get shocked. Solid elements, liquid elements and compounds all have no charge. They're all neutral. Atoms are neutral. So solid potassium is no different. So 7K would be 0. When it's in a compound, if it was KCl, then it would be +1, -1, because it's an ionic compound using charges. That's the point of the homework. But I neglected to tell you that, sorry. We'll deal more with that down the road. All right, 9, Na +1, O -2. 11, Mg +2, Br -1. 13, K +1, Cr +6, O -2. 15, N -3, H +1, P +5, O -2. 17, Fe +2, Cl -1. 19, Fe +2, O -2. 21, N +1, O -2. 23, N +4, O -2. 25, N plus 3, O minus 2. 27 is a 0 on the AG. 29, CA is plus 2, C is plus 4, O is minus 2. 31, C is plus 2, O is minus 2. 33, S is a 0. Don't worry about those. 35, Mn plus 2, S plus 6, O minus 2. And I'm going to stop there. There's no way everybody here got all those right. So please tell me which ones you want me to go over. I will go over 13 and 15. So besides those, what else? There's got to be other mistakes you made that you're confused about. So that's normal, that's okay. So just, what else?
And what did you say,
15. I'll go over that in a second. So I'll do 13 and 15 on the board. I would like to go over two more of them. Let's say 4 of these. 29 is a good one, yeah. 13, 15, 29. How about one more? 35. All right, good. Those are all good. 13, 15, 29, and 35. Good. All right. So these are hard because there's 3 elements, and some of them there's subscripts that screw everything up, right? So 13. Here's how we would do this. We have K2, Cr2, O7. There's 2 ways to do this. You can keep it as a compound, or go to table E for me, and we'll go to table E. Find the polyatomic ion on table E that's in this compound. Dichromate. So you can kind of separate this and say, all right, I have K, and that's bonded to Cr2O7 minus 2. So that's, you can do it one of 2 ways. Keep it all together or kind of separate it. So I'm going to do this one first here. I'm going to separate it, and then I'll show you how that relates to this. By the way, this is like one of the hard ones. 13 and 15 would be like as hard as you're going to see. Okay. So K is plus 1. How do we know that? It's the only charge. You go to your periodic table, look in the top right corner. That's the only charge in the box. So it has to be a plus 1. Okay, so that's easy. K is plus 1. Because remember, this K is the same. Now, the reason I'm telling you that maybe you want to separate it is it makes it a little more manageable. So we don't have to worry about the 2. It's got to be plus 1. So that's taken care of. Now, you have 2 and 7. When you look at all of them together, it's a little like overwhelming, maybe hard to figure out, because you know it has to add up to 0. Well, if you go down here, and this is going to help us answer the bottom ones. If you go down here, all the charges inside this parenthesis must equal -2. So we have to have a total charge of -2 because that's a -2 ion. So now you go to your periodic table and you look up Cr and O. Well, if you look up Cr, how many charges are in the box? And what are they? Can someone do that? What are the options for Cr?
+2, +3, and +6.
+2, +3, +6. All right, so Cr has to be one of those 3. Okay, now oxygen only has 1 charge. What is it? -2. -2. So, the reason I'm separating these is now it's a little easier for me, or you, hopefully. So, eyes up here. If I have 7 oxygens, what's the total negative charge here?
-14.
-14. Right? That's just the total charge, not the oxidation number, not the charge. So on this sheet and on Regents exams, they're going to give you this compound and say, what is the oxidation number? What is the charge? That means the same thing on oxygen. It's not -14, it's -2. I just want to be clear. This is the total charge of all the O's, but -2 is the actual oxidation number. All right. So now we're trying to figure out what is Cr so that all of these charges add up to -2. Well, I know that this down here needs to be a +12. In other words, 12 minus 14 is -2. Well, if I have 2 Crs, that means each one must be +6. That's how I would do this problem. So I know this is -14. I know this needs to be +12, so we have a -2 overall. That means each Cr is +6. Does that help a little bit for some of you? Now, if you don't like that, forget it. I think this is harder, but you can do it this way. You can say, all right, K is plus 1, so that's a plus 2. I don't know what CR is because there's 3 options. I do know O must be minus 2. So I can say, all right, this is plus 2. 2 and 1 is 2. 7 and minus 2, that's negative 14. So what does this have to be? Well, remember, now it's a compound. All of these have to add up to 0. So this is still, it's the same math, plus 12, because that's going to be 14 and that's going to be negative 14 adds up to 0. So you get the same result, obviously, it's the same thing, plus 6. But it's just another way to look at it. You can do them all together, they add up to 0, or separate the ions and then figure it out from table E. Questions? There's a difference between thinking it's difficult because it's just hard to figure out, but you know what to do, versus you have no idea what to do. It's 2 different things there. So if you have no idea what to do after I'm done going over these next 3, then you have to come talk to me and we can do more practice problems. But if you can see the method and you get it, it's just hard to actually do it, I'm okay with that. You just, need to get either way, you should probably talk to me, I guess. But I just want you to be aware of what you're thinking. Is it because you have no idea what you're doing, or because it's just difficult? It's 2 different things. All right. And I can help you either way. You just have to let me know. All right, 15. 15's tough because you got all types of subscripts. You got 3 of these things, and then you have PO4. So we have 3 N's. We have 12 H's. We have 1 P and 4 O's. So if you try and do the charges with this whole compound, it gets pretty complex. So I can start there, but I prefer to separate it and go to table E. But let me do this first. So if I look up all 4 of these on the periodic table, this is the only one that has 1 charge. P is minus 3 plus 5. Is there anything else? Someone look that up. P is...
Minus 3 plus 3, plus 5.
Oh, plus 3 and plus 5. Okay. Hydrogen is either plus 1 or minus 1, and then nitrogen has like 7 or 8 of them, right? I don't need to write them all down. There's a ton of them. Okay. So the reason I think it's hard to do this from your perspective is because you don't know which one of the nitrogens to use, which one of the hydrogens, and which one of the phosphorus. See, when you had something like K, when you had this one, you know this is plus 1, you know this is minus 2, so if you know 2 out of 3, it's a lot easier. This one, there's 3 question marks, right? We don't know which one to use. So I give you a little help, obviously. That's why I'm standing up here, I suppose. Hydrogen basically is always plus 1. The only time it's negative 1, which is rare, it's when it's bonded to metals like sodium hydride is a compound. In this case, it's minus 1 and plus 1. But I really don't think we need to worry about it, so don't worry about it. Basically, it's always plus 1. So that helps. So we know this is plus 1. We know this is minus 2. But now we're still confused with the N and the P. So from your perspective, it's almost impossible to do this without splitting the 2 ions. What do I mean? Well, NH4 is on table E, it's plus 1, and PO4 is on table E, it's minus 3. Now it becomes a lot more manageable because I don't know N, but I know this is plus 1. I don't know P, but I know this is minus 2. So now I know one, and I don't know one. So it's easier to figure it out. Up here, there's more question mark. We don't know what these are. That's harder. It's a lot harder to do that, in my opinion. So let's go down here. All right, so if I have 4 H's, that's a total charge of plus 4. So if all of these inside the parentheses must equal plus 1, that means N is negative 3, because I only have one of them. So negative 3 and plus 4 equals positive 1. So my answer for N is a minus 3. I do the same thing over here. If this is negative 8, and I need all of this to add up to negative 3, this must be a plus 5, because that adds up to minus 3, so that's a plus 5. And that's how I would do that. I wouldn't even mess with the compound. I would look them up on table E and do it that way. But that's about as hard as it gets. tried to go slow. I went a little fast at the end there. Questions? What do you think the biggest mistake kids make with this? So they know how to do it. They start labeling things, but they make a mistake. Where do you think the mistakes are?
Maybe they add subscripts that are the.
Yeah, so they can add, right? So, like 7. Yep. Or some kids will, for some reason, carry this through to the P. I don't know why. So they'll say, oh, there's 4 P's. There's only 1 P, right? So subscripts, that's the biggest mistake. Or they ignore it. Yesterday, who was it? I don't know, somebody in period 6. They came up and showed me something. And I said, no, you forgot the subscripts. And he was like, oh.
Right, Tyler.
No, it wasn't Tyler, but I remember, but you don't need to know the name. That's not important. The point is they forgot subscripts. That's typical. That's normal. The good news is most Regents questions are like, 25. N2O3. If you know the O is -2, then the N's got to be +3, so they add up to 0. That's a lot easier than this, right? Sometimes they give you one like number 13 or number 14. 14 is kind of typical too. 14 is easier than 15. All right. What was the next one again, Zeke? What'd you say? 29. And then there was one more, right? Didn't you say one? Yeah, 29. Here we go. So this should be easier now that we just did those two together. So what's the charge on Ca? +2. What's the charge on O? -2. This is a compound. It must add up to 0. The total charge here is -6. There's only one of those. The total charge is +2. So what is this charge going to be? Well, whatever this overall charge is the charge on carbon, because there's only one of them. It's got to be +4. So that's a +4, so all of these add up to 0. And that's the part that some kids get confused with as well. They say, well, 2, 4, and that doesn't add up to 0. You're right. It's the total charge, so you got to take the subscripts into account. 2 different concepts. The charge on the atom versus the charge on 3 atoms, or the whole thing. These charges will always be on the periodic table. Always. Another way to do this. CO3 is on table E. This is -2. So that's -6. This must be a +4 because these two add up to -2. That's another way to do that. Okay, and 35. 35 is harder than that because of the Mn. So MnSO4, right? Yeah. All right, here's why it's hard. Mn, I think, can be +2, +3, +7, 6?
+1, +7.
2, 3, 4, 7?
Yeah.
Okay, 2, 3, 4, 7. Sulfur can be -2, +4, +6, and O is -2. So again, I go to table E. I say, all right, SO4 is a -2. That's on table E. So if O is -2, all right, time for someone else to give some answers here. I gave you the answers, but someone explain to the class, why does it make sense that this is a, what is it? I read the answer, so everybody has it. +6, why does that make sense? Yeah, -8, this is -8, this is +6, together that adds up to a -2. So now you can say, okay, S is +6. Okay, good. Well, if this side, right, this side is -2 of the compound, there's kind of 2 parts, a negative and positive, it's ionic, then this side must be +2. That's how you get the Mn is +2. So first figure out the S and realize the sulfate ion is -2, so this side must be +2 to add up to 0. Again, some of these aren't easy, but as long as you know how to approach it, you have a much better shot than probably before you got it. All right, now on the bottom, so 37 through 51, but the odd ones, I'm going to have you do those for tomorrow. So I don't know if you had an idea or not, but do the odd ones on the bottom. I'll check them again tomorrow. Don't do 51. That one's really weird. So don't do 51. So all of those, the arrows there are showing that OH is -1. NO2 is -1. CrO4 is -2. So the OH, the whole thing is -1 on number 37, not just the H, the whole thing. Same thing, NO2 is -1. So if you need to do parentheses, do that right now, so when you go to do it later, you're not all confused. That charge is on the entire group of atoms, not just the last one. So not just the oxygen, it's also the Cr. Am I making sense as to what I'm telling you right now? Yes? Emily, you with me? Brady, you with me?
Yeah,
You sure?
yeah.
And out again. Okay, so, also on the top, do even. Repetition is good for this type of problem here. So do the even ones on top and the odd ones on the bottom with the charges. So basically you're skipping 38, 40, 42, 44. Obviously you know what even means. So don't do the even ions, just do all the even above it. Okay, so you got any notes? Let's move on. All right, so yesterday, we talked about single, double, triple again. Single bonds are the longest, weakest, triple bond shortest, strongest. Is that it? That's all we wrote, and we played around with that thing. I showed you the, that was it, right? Yeah. All right, let me look at my notes here. Took a while to go over that, that's all right. Oh, all right, I'm gonna write 4 molecules on the board. I want you to write these down. We'll go CS2. We're going to go with BR2. We'll go with I2. So, out of those 4 compounds, I want you to, and if you want to do it mentally so you don't screw up your notes, that's fine. I want you to label which ones are nonpolar with polar bonds and which ones are nonpolar with nonpolar bonds. And then we'll talk about it. So which out of those 4, which ones are nonpolar molecules with polar bonds, and which ones are nonpolar molecules with nonpolar bonds? You having fun today, Rick?
Yeah.
That's good. So, catch. Okay, everybody that has a, oh wait a second. Everyone who has something, hold it up. Okay. All right. There's no coincidence here. Why did I make those? What are those? Yeah, which one's which? Either one.
Yeah.
Right? So Selim, hold that up high. So Selim's holding BR2. Reagan, hold that up. That's I2. Okay? So green to green, yellow to yellow. Hold that up. What's that? CS2. Good. And CF4. Good. No. Sure. Okay. All right. What's going on, Zeke? Nicole, there's something in the office for you to get after class.
Oh, okay.
Can you wait? You only got 6 minutes.
Yeah, I can.
Okay. All right. Yeah. So, what does the stick represent?
A bond.
A bond. Good. So we have here. Here we have 2 different colors, and then here we have 2 different colors. Here we have 2 the same.
It's okay. I didn't hit her.
2 of the same versus 2 of the same. Now remember, these are all covalent. What's another word for that? Molecular. So they all do what with their electrons? Share. But polar means they share unequally. Non-polar means they share equally. This is nonpolar. CF4 is nonpolar. These are all nonpolar, the molecule. This is nonpolar. This doesn't look super symmetrical, but it is. Okay? These are obviously very symmetrical. Okay, these are not. So all 4 are nonpolar molecules. I already told you that. What's the answer to the question? I2 and BR2. These 2 are nonpolar molecules, but the bond is also considered nonpolar because they're bonded to themselves. The electronegativity difference, right? The difference between them is the same. So whatever BR is, I think it's maybe 3. And I is like 2.8. So, you know what? Let's look these up. Someone look up BR and I for me, please. So we have the right numbers written down.
I is 2.7.
2.7 and what?
3.3.
3.3?
Just 3.
Oh,
3.0.
got it. Carbon is 2.6, sulfur
2.6.
That's stupid. All right. 2.6 and 4.0. I should have just done CO2. Yeah, because oxygen's 3.4. All right, so let me that backfired on me. I didn't think about that. So it's supposed to be any bond with a difference in electronegativity is automatically polar. Okay, so let's focus on that for a second. So if I was to take 3 of these off and just look at that, the carbon and fluorine in one bond here, the fluorine wins every time. So fluorine's pulling out on all of the electrons. So the bond itself, there is going to be a difference. It's not sharing equally. The fluorines will have slightly more. But because the whole thing is symmetrical, kind of looks like a plus sign, then it's nonpolar. But again, the bond itself, that's going to be polar because there's a difference. These 2, there's no difference, so it's called nonpolar bond. No one's winning. No one, they could tug all day, all long, the rest of their life. No one's ever going to make any progress because they're identical. So that's called nonpolar. Everything's perfectly equal. Here, according to the numbers, it's supposed to be nonpolar bonds, but they're actually not. Because there are 2 different elements, there's going to be a slight advantage for one of them. Sulfur would slightly win. I know that doesn't make any sense, and I'm sorry I picked the wrong one here. But if you understand what I'm saying here, then that's all I really care about. I should have used oxygen. You guys are the guinea pigs, period 6. I won't use that. So the point is, if it's 2 different elements, there's going to be some sort of, someone's winning. All right, even if it's slightly, so that's going to be polar bonds. All right. I'm going to add questions to your lab. You're welcome. And this is what you're going to do. You're going to identify in lab which ones are non-polar molecules with polar bonds and which ones are non-polar molecules with non-polar bonds. So I'm going to add that to the list of things you need to do because it's just more practice. Okay. So I'm going to move on past that. All right. Now.
Corey, your iPad needs to be charged.
Yeah. What's going on?
Nothing.
Are you laughing at this thing? Just doing this? All right.
Why is that?
Thought that was funny. It was like springing around.
I don't have the